Hey guys, Harrison here. Welcome back to Harrison Inventions. Today, this is the second part of my group project that I talked about in the last video. So this is the Apex Predator. I don't remember if I mentioned it last time. Remember, it was a long time since I made the last video, about a month ago. But yeah, so this is the robot and how it is now. So as you can see, it's a lot different. Ignore this right here for now. That is part of the robot, but I'll explain why it's not on there in a little bit. But yeah, so this is pretty much what the robot should look like. There may be like one or two things that might change about this robot because there are like one or two things that we need to just check before we actually confirm that this is the final design. But for the most part, this will be what the robot will look like. The biggest exception is this. So because this can't actually, uh, as far as I'm aware, there's not really a way to warp it in the way that it would actually run along here as the belt. I believe the belt was working last time, so. But I'll explain it real quick for those who may not have remembered the last video. Basically, this turns and it's connected via this belt onto here. I just used the belt tool. I'm not sure where it is within here. It's somewhere in this giant tree. But but instead of actually like using a model belt, it uses just like the system's knowledge of how belts work. But that's just supposed to be the belt that goes there. But anyway, so I'm just gonna walk you guys through very shortly again what this is for, and then we're gonna dive into what this is, how I made it, and just like what each piece is for. So this is for the Beetle Weight BattleBots tournament within my university. And so myself and a team of others came up with the design, and then myself and one other, we made all the models for this. And the reason why you make a model is because when you're building a project, even though having a drawing is very useful, having a 3D model really solidifies what you're building, what you're making, and it really makes you think about, oh, how is this going to be connected? I need a part here. How many parts do I need? It just really brings the thing to life without having to really spend that much money on real materials and figuring all that together. Also, it's very useful because I can print out most of these even if they're not going to be made out of the material. Sadly, I don't actually have the electronics. The other person that I said made a lot of the models, I gave him the parts for a little bit because I've been holding on to them for a long time. And we went and we printed out some of these to see how everything fit and to fix some stuff. And he bought a few of the screws. We went to just the local Ace Hardware. And since he bought some of the screws and we had already put it together just a small bit, I thought it would just be better just to leave them with him. We actually are planning to return those to me so that way I can print out a few of these because I just need to do a little bit more testing with some of these models in particular. Like, for instance, with this, this was a little bit too big for the motor, so we had to make it smaller. And then I sent him basically just a CAD file of just like a ring. That's the that's the diameter of like this circle right here, and he was told me like how much it fit and all that kind of stuff. But just to make it easier, I'm just gonna get those and yeah, sadly, my 3D printer is manual, so it's actually really hard to work with. I don't know if his is manual or not. I'm guessing it's not, but yeah, but hopefully I'll get mine working and we can print these all out. But anyway, so what we do with Beetle Weight BattleBots is, if you've ever seen the show BattleBots, I showed a clip in the last video. I'll put that a link in the description of this video, or in the iCard, or at the end, or something like that. You'll find it if you look for it. And if you watch that, there's some clips of BattleBots. But essentially, this robot runs via these wheels, and we control it through a controller, similar to like an Xbox controller or something like that. We don't use an Xbox controller, but for it's very similar in the sense. It's more like an airplane controller actually because of the parts we use, but or electronics we use. But so we use that, and it's kind of like playing with an RC car, except these have metal on them that, like how I'm showing here, spin, and they can be very deadly. When we actually put the robot together, when we like have all the electronics in there geared up, we actually have to put on a clamp I don't have one, so I can't show you guys. But that clamp is literally just in case the robot malfunctions and it spins around a lot. It spins very fast. It could slice through your, I don't know about through your hand, but it can definitely slice you. I mean, it's tearing up the nylon, which is a material that's pretty strong-ish. That's made for 3D printed parts, and it's tearing up. It's not really tearing up the metal, but it can most likely. I wouldn't be surprised if it didn't like tear through the skin of your hand at least. Ah, what a lovely day in the park. Oh, what's that thing over? But yeah, it can be dangerous, so just for any of you who want to build something like this, just make sure you take the proper precautions. This is my first time ever making, I'm not my first time making a robot, but making a battle bot. But I'm within a club, and people who are running it are very experienced, and so they know what they're doing, and so they have all this great safety advice. So if you do decide to do this on your own, make sure that you talk to someone who's done it before or something, or look up safety guidelines. Just be very, very careful, especially when you actually start putting the electronics together and making it so it actually can move. If it's one thing just to have this and not have any electronics connected, it's another thing to have it all connected and not have any safety precautions at all. But anyway, so this is the spinner here. This is the weapon. This will rotate like how I've been rotating it to chip off pieces of other robots. These are wedges right here. Their whole purpose is to hopefully, if you could imagine another robot like this, and this rolls towards it, hopefully get the robot slanted upwards a little bit, and then when this rotates this way, it's supposed to kick the robot into the air. I did like a very small demonstration in the other video, so again, if you go watch that, I used like some just basic like um, Microsoft Paint and whatnot to just show that. But anyway, and the reason why we decided that would be interesting is because these are beetle weight, which means that they have to be 3 pounds at the most. Let me see, I can show how many pounds it should be. Yeah, so this is 2.54 pounds. Obviously, it could be heavier or lighter than this because not all of these are assigned the right material for the right weight. So hopefully we're gonna have to double check and make the whole thing and check that it's under 3 pounds. But that's really the only, there are a few other limitations, but that's the main one. And so, 3 pounds is pretty easy to fling across. And these robots, they fling all the time. So that's what our goal. We wanted to hit him as hard as possible. And the reason why we chose two instead of just a single spinner, I'll try to show an image of a couple of different types of BattleBots. Ours is called a vertical spinner, which means that it spins vertically. There's also horizontal, which spins the opposite of this, so it's kind of hard to demonstrate. But here, like it would spin the way that my mouse is spinning right now, rather than this way how it does. There are some other types of bots, but those are the very simple ones that move. There's also some that, like these, they're not really wedges. I think we call them like pitchforks or something like that. But imagine, except instead of being these two very thin, there's entirely across the entire robot, and it doesn't spin at all. Its whole purpose is just to get underneath the other robot and try to turn them over. So there's also bots like that. There's a lot of different types of bots. The reason why we chose to go with this double prong design, which is called a Peter bar, is it's a lot easier with our materials than making just a full slab of metal that is the shape of this. And then also with two things to attack with, we thought it would be a better chance of flipping the other bot over, as well as just doing damage in general. And the way that it works is like I've mentioned. I'm not sure where the... Oh, here we go. I think I highlight the belt. Yeah. So the belt will go here, and that's the same belt that's over here. And when we put the belt on, it'll be in this like little area right here, and also on here. And when this motor spins, which spins this pulley, it will also spin this. And now you may be wondering how the robot moves, and you can probably see these wheels. So kind of like a car, we have active wheels and not active wheels. So these wheels have motors and spin, while these wheels are they just sit there, And their whole purpose is just to make sure that because this robot's kind of long, that it doesn't drag along the ground. And you may notice that our wheels are kind of big compared to a robot, so they touch the bottom and the top. Now, originally, the reason why our design had this is because we thought that this spinner right here was going to be a little bit further down. So we wanted it to be that if we flipped over, we would still be able to drive. Now, because this is in the air, you could say almost, when the bot does flip over, since this, if we just spin this, it should be enough force to flip back the bot back over onto how it should be. So I'm not sure if I can. Here we go. So if the bot was flipped over like this should hopefully spin, and that would hopefully flip the bot back over like this. But originally, we wanted it that our wheels would poke a little bit, so if it did get flipped over, we could still drive a little bit. Most likely, we don't need this feature anymore, but there was no point this late in the game in trying to remove it, so we just left it. And that's why we didn't do that with these wheels. Also, making them smaller made them able to fit in this little nook and cranny. And you may wonder what this nook and cranny is for. And this is a shield to just protect our wheels from other robots. From just because if they try to attack from this side and our wheels are exposed, our robot can't move. And if your robot can't move, there's just serious point penalty and different things like that. Now let's talk about the insides. Oh, actually, I do want to mention just one last thing. This plate here is also for the same purpose of just protection. Anyway, on the inside, I've already mentioned the spinner. These towers just hold up the spinner in place. That's really it. These are the drive motors, so they just drive like how the name is. They're just used for rotating these wheels, so that way the wheels can move us. And then here is the weapon motor. It's called a brushless motor. These are not brushless. Um, I don't remember the exact difference between a brushless motor and a brushed motor. One thing I do know is the brushless has to go through another piece of electronics, as so does the drive one. But um, these are used in, I think it's model airplanes is what we got this motor from, I believe, if I remember correctly. But this motor is just better for spinning this weapon here, so that's why we used it. And we put on a pulley instead of putting it on directly onto this motor, just because we thought it would have a better chance of just holding on to the motor a little bit better. And so yeah. And then we attached it here, so that way, you know, it wouldn't move. And the reason why there's a hole is because there's a little bit of the motor that sticks out. And interesting about this motor is this entire part of it moves that I'm highlighting right here, as well as a small bar that comes out. The bar is very similar, if I make these transparent, to the bar that comes out of the drive motors, kind of like that. But we decided it would be easier to put the pulley onto the much larger part of the design. Okay. And then these are the drive ESC and the weapon ESC. I don't remember exactly how they work, but we use these to just control the drive motors and control the weapon motor. This is the receiver, and so like that controller type thing I was talking about before, we connect that to this receiver, and this receiver is able to talk to these, and that's how we're going to control the robot. This is the battery, and then this connects to the wires that come from the battery, and it's an on and off switch. So instead of being an actual switch, you use just like an Allen wrench, and you just turn this. And the reason why it's like that instead of a normal switch is because if it's a normal switch, this robot's getting banged around a lot, and so we don't want it to turn off too easily. We obviously want a way to turn it off because of safety reasons, and also we just don't want to have to unplug the battery every single moment. But yeah. Oh, there is one more thing actually I forgot to add to this. I need to add the top plate. My teammate made the top plate. I'm just the one who's supposed to put it all in here. So that might, I guess that will change the design a little bit, but that's about it. Anyway, that is mostly all the pieces of the robot. And then obviously there's models of the screws and stuff that we're going to be using, as well as like this giant screw which we're using as an axle and all that stuff. So what these are going to be made out of, this is going to be made out of AR 500 steel. It's very strong, very hard to cut through aside from the laser that we're using to cut it. So I had to make sure that it was really right before, we had it cut. Uh, if I get pictures before the time that I upload this, I'll add those. If not, I'm probably gonna make a third part of this video showing the actual real life robot and maybe a little bit of excerpts from the competition. But yeah, um, most of this robot is gonna be made from nylon. I talked about a little bit in my last video about this, but nylon is just another material you can make from 3D printers, like PLA, but nylon's a lot stronger. And then these parts may be made from nylon, or we're going to be using, I don't remember the name of the plastic, but it's plastic that you use for like cutting boards and stuff. So we might laser cut some of that and then melt it a little bit or heat it up to try and bend it. I'm not exactly sure we're going to be able to make this out of that. We hope to, but we'll at least probably may be able to make our prongs out of that. These wheels are both going to be made out of foam, maybe TPU. Our pulley will also be made out of TPU most likely. TPU is another material like nylon to be 3D printed, but it's a little bit more squishy. The reason for this is because this gets hit a lot, because the metal will probably be hitting the other robot and then maybe even the spinner on the other robot. We want this, if it's a little bit squishy, it means that it takes the impact a little bit better. So, like if I have something really rigid, like metal, and I hit it with a hammer, it's probably just gonna like dent, or if it hit it with enough force, it'll break. Versus with rubber, if I hit it, it smushes around and distributes the force more. I'm not exactly sure the exact physics of it, but you guys can most likely guess what I'm trying to say, that if it's squishy and it gets hit and the belt, it moves around a little bit, it's less likely for that to just snap and break. And it doesn't need to be hard and tough because it's on the inside of the robot. So that's why we're going to use that material instead. We decided to use a timing belt. So the difference between a normal belt and a timing belt is the timing belt has these hooks. Now we might actually just flip this inside out and have the hooks like on the outside of it. The whole reason why we get a timing belt is just because they don't stretch as much as a normal belt. But other than that, we really didn't actually need these grooves. I don't even know if these grooves will line up with those grooves. So we're probably just going to flip it inside out. But yeah. Tell me in the comments if you have any questions. Before I wrap this up, I will just give you guys a four-way view of this, just in case you're curious. And then I will show you guys all of the pieces of this. In SOLIDWORKS, you can make things explode. So, let me just show you guys all of the pieces. So these are all the pieces. I just imported this as the model we made, so that's why that's not taken apart. But yeah, so these are all the pieces. So it's a good amount of pieces, and it took a while to make this, but now that we have it all made, it should be pretty easy to put together. I will definitely show you guys in the next video. Well, not the next video, but a video soon. Everything in real life, as well as the top and all that juicy stuff. Alright, I hope you guys really enjoyed the video. Leave a like, leave a comment, subscribe, and let me know any other projects you guys would like to see. Alright, goodbye.